Hi, hi everyone. So I'm Gaëtan Rivet. I'm a software engineer at NVIDIA. I've been working on user space data path implementation in OVS for a few years now. So first OVS DPDK, but then also integrating the user space data path with our framework Docker. And when we integrated those user space data path, we had to contend with controllers or other projects that wanted to observe OVS. And we always had some kind of friction when moving from OVS kernel to the user space implementation. And so when that happened, we wanted to streamline and align a little bit because all of those projects will have some kind of own observer and their own kind of exporter implementation of OVS metrics. And we wanted them to see the same metrics. We wanted to have more control on what is exposed, what are the relevant information about OVS. And so I started a small project inside OVS itself. And right now in this talk, I will present this work. I submitted the patches for upstream integration. And so I will describe what is the aim, the reason some of the choices were made, and finally, how to use it, how to interact with this new framework. All right, so the target is Prometheus metrics first. It's not the only target, but that's the starting point, at least for this framework. So I want to describe for you the goal and what it should look like at the end so that you have a clear idea of what it will generate. So first, Prometheus Open Metrics, a very short introduction. I guess most people know already about it, but I want just to be clear on where we go. So Prometheus is a monitoring system. It's alerting, and also it's a database to keep a time series. It presents mostly, I mean, as far as this exporter is concerned, it's mostly defining a data model. And so there is a standard, or at least it's de facto standard. It's not actually in IETF, for example. Also, it's widely deployed. I think, actually, I saw maybe last week some statistics that maybe OpenTelemetry was more active than Prometheus. But still, Prometheus is widely used. So I think it's a nice initial target. Finally, just one other thing to note is that Prometheus does not demand a predefined schema of the data that we want to send. It's kind of free-form in a sense. So it's only a starting point. I want to note that this framework I'm proposing for OVS is generic in its output. So right now, it's Prometheus as a target, but it could become something else, maybe OpenTelemetry in the future. So the data model of Prometheus, that's what we will try to address. First, there are four metric types that are defined, counters, where you have a value and the value only increases. You have gauges, where the value can go up and down. You have histograms, so you have a distribution of values over predefined buckets. And summaries, where it's all the values are distributed over a set of quantiles that are determined from their own distribution. Yeah, okay, so the font is not great, but at least it should be readable. So ultimately, what exactly are we sending? What are we generating? Just metrics. So metrics are just lines in here it's in text form, where you have a name, you have an optional list of labels, you have the actual value, and you have finally an optional timestamp. So here you have just a few short examples, just to understand that the labels, for example, are a list of key values. And then the timestamp serves for the analysis to know whether there have been some reset or things like this. Finally, there are some additional optional lines about help, or for example, describing the type of the metric and maybe the unit of the value that is displayed. When you want to show a histogram, the histogram has to respect some formatting. So you have actually a set of different lines that are with the suffix bucket. You have a sum, you have a count, and you have a special label that should decide whether these values are less or equal to a specific value. Finally, one important thing is that in Prometheus format, the buckets are cumulative, unlike the histogram that currently already exists in OVS. Finally, for the summary, it's pretty much the same instead that, except that for the less or equal label, it's now called quantile, but otherwise pretty much same logic. Okay, so this is the data model that we want to present. That's what we want to generate. Now, how to integrate it in vSwitch. So vSwitch already has natively metrics that exist. It has counters, it has gauges, it has histograms. I haven't found summaries, but here, those are already metrics that are accessed and used by people that actually observe OVS today. However, those observers generally use third-party exporters that have many implementations. So you have a kind of galaxy of different exporters. Generally, well, they will observe not all of them the same thing. A lot of them will assume that by default, OVS is running in OVS kernel mode. They are also implemented several times. So in each of those implementations, you have a chance that the set of metrics that is selected and exported is different. So of course, it makes it more difficult to align on a single dashboard or reuse them across the OVS instances. You have competing implementations. And finally, a thing that was bothering me when I tried to integrate with those was that they require to do a lot of CLI calls to access those internal metrics that already exist in OVS. So they generate those, but by doing a lot of calls in the main control thread. And also, very often, considering that they assume that it's running in OVS kernel mode, they will not treat OVS as the primary source of truth. So for example, they will extract interface statistics from the kernelnet device instead of asking OVS itself. So whenever you switch to user space, you lose a lot of information. Also, considering that we implement new features in OVS, we wanted to be able, as developers, to control when they are exposed and without having to modify the whole vertical, meaning without having to go into each of those different exporters and enable just these new features to be observed. All right, so that's why it exists. The way it is exposed, the proposal there is that you have a systemd service, so OVS exporter. You have a default HTTP port to access this set of metrics. You have actually also a local command, if you want. It's a single CLI command that will expose or access the same textual information, but here it's directly without using the HTTP server. You have Python bindings, so it's just a few classes, a few objects that will allow you to manipulate those metrics natively in Python. And then in this framework here, only 3 of the Prometheus types are supported, so counter, gauges, histograms. Summaries didn't really exist yet natively in OVS, so I didn't want to add support for it. And that's mostly it, meaning that now, if you wanted, using this framework, if you add a new feature and you want to observe it, you can just add the relevant markers in that framework, and it will immediately expose them in that output. So right now, the initial implementation covers resource consumption in OVS, interfaces, so the state of the data path, and then some information about OF proto execution. And considering that at NVIDIA, our focus is mainly about hardware offloads, we have also additional statistics about hardware offloads. Okay, so I just want to show how it works or a bit how it runs, but we'll see if we can actually see it. Yeah, it seems to be shared. All right. No, okay, yeah, I see. All right, so it's a very simple configuration. I just wanted to have some ports added. It's running in kernel mode. So you have just 3 interfaces there. I show first here the actual CLI command. So it's local access to this output. So you see here what it looks like if you just want to access it. Here with the -d parameter, I enable what I call the debug page. So for example, here you can access additional counters for the coverage. So coverage is a high volume metric. So I wanted to hide it in a sense behind special page. Now I will enable the exporter service. So you have a small configuration available. And once you enable it, you can then just do HTTP requests to it. You have a default port. And inside it, you have pretty much the same information. So here you have some metrics about the data path. So here you have one data path for the kernel. And then you have also each of them for interfaces. So you had 3 interfaces, 3 ports that were added previously. So you can see them here listed, each of them. Okay, so that's pretty much the result of this. Now let me get back to the previous. Right. But now it's not sharing, I guess. Yeah, can you? No, okay, that's great. Right. All right. All right, so this is just the recap of how to use the service, but it's kind of obvious. But okay, so how do you integrate with? Yeah, it's good. Okay, so how do you integrate with this framework? How to use it? How to generate actually this output that we saw just before? So you have metrics tree. So it's a hierarchy of metrics that are exposed. This tree describes a structure in the OVS module. So it describes how to navigate in the different modules of OVS. So you can see here kind of just a rough generic overview of those different modules that you can access. So you start from a root. The root is defined once per process. So you have currently one for the OVS vSwitch D, but actually it's available as a framework in the library. You could create one per other processes, OVS DB server, whichever. And then each of the metric that you want to generate is a leaf. So anytime you want to add a new value, you create such a leaf. The internal nodes of the tree reflects then the structure. So they describe how to navigate inside of all of those modules. So now I will describe, how exactly those internal nodes work, because that's kind of the difficult part about the framework. So let's say, for example, you have some features that are behind configuration nodes. So for example, here you can disable or enable hardware offloads. So you have a special node that will be a conditional type where you will say, if hardware offloads is disabled, then you do not create those offload metrics. You have the same, for example, you have special metrics that will be only available in the user space data path. So here you will call the dpf isNetDef function, integrate those in this conditional node. And if it returns false, you do not visit all the following children. So you will not emit the metrics that are related to that user space data path. The other important node type is the collection node. So here you can imagine that in OVS you have some objects that are in collection. So you have, for example, multiple data paths, or you have multiple interfaces that are available. So you need to have a way to expose them. So you need to iterate over those. So you have those two structural nodes, if and for each, that needs to be used to navigate this organization. So in order to generate the output, you visit the tree, and so you interpret each of the nodes. So execute the for each, execute the if, and then read the values that are in the leaves. Once it's interpreted, it is formatted into a Prometheus format. But actually, this format path is generic in the sense that right now it's Prometheus, but nothing prevents us from just moving to different other kind of formats in the future. So in the end, you have a static tree that is defined in the source code, and then you register the leaves, and the parent, all the parent chain of those leaves are themselves registered. So only the registered leaves are actually added to the process, meaning that if you do not enable those in your own process, you will just elide those. Now, I will just go quickly about a few examples. All right, so I want to describe the set of metrics that were defined in the OF Proto subsystem. So you can see here that you have a different kind of nodes. So you have the root, which is implicit, but you first describe the subsystem. Here it's OF Proto. Then you have already the first leaves, which are just a set of entries. Then you have a collection, so it's a for each node, then a set of entries, collections, and you have a last special node, which is labels. So I will briefly describe those. First, the array of entries. So it's a very simple read. That's why I wanted to start with it. You describe here an array of entries, and here it's a variadic list of, here it's a gauge, but you can have gauges or counters. And all of them, once they are added here, you describe how to read it. So you have a callback that needs to be executed. And once it is executed here, it will generate this output right now. So you have the help. You have actually also the path that needs to be displayed. So you have this hierarchy there that is generated in the names themselves of the metrics. Now, for a more complex example, okay, so I guess we'll have issues later, but here it's a for each node. So you have to describe how to iterate over, here it's all the existing OF Proto instances. So here you describe two for each nodes. Each of them use the same callback. So the callback describes how to recursively visit all of those nodes. So you do the iteration inside this callback, and then you do a recursive call of this visitor context on top of that current node, and then it will, for each of them, it will multiply the execution of the tree visit. Additionally, here, something that is important to note is that whenever you have an iteration, it is very often useful to label those, just to separate them, to understand exactly which instance we are visiting. So here, the first node, the first for each node has two labels that are defined, so name and type. And you can see here that they generate labels here for the name and the type of this OF Proto. So we take them from the OF Proto instance directly. And then you can also have a different kind of iteration where you do not have any kind of labeling. It's very often useful to hide those. For example, if you want to access here, this one will be used by OF Proto DPIF, because we will actually label the DPIF themselves instead of the OF Proto instance. So we don't want to inherit those additional labels. So here it's a slightly more complex read of a set of entries. So previously I was only reading a single entry, but here it's kind of the more useful version where you read actually several entries at once. So here it describes 3 entries. In the end, for example, in the port entries, you can have many, 20, 30 entries. So you don't have to generate or to write a callback for each of those entries. It's kind of wasteful. So here you just have the example that, okay, you can set them all at once, and you describe them all at once here in a single array of entries. Okay, the label nodes are kind of, just a short special node where you can set arbitrary labels for any children that will visit that node. So here you can add, for example, here you have the set of the bridge name, the name of the interface, the type, the port, and so on. So if you want to have special information added, you create a label node. Actually, it's still the for each. The label node is here, and then you can set those labels specifically. And finally, just the conditional node, it's just the matrix if. So here you describe a Boolean callback that if it returns false, you do not continue the visit on this node. I mean, no children is then visited afterward. And that's kind of it, actually, from that. Yeah, okay. Histogram node is just a reading node. It's not really important. So that's all you need to know, meaning that here, the matrix framework, the purpose is to know where to find the data. And so it describes to you how to access the content of OVS and then structure them in a format that can be consumed. Here, it's in a Prometheus format. So you have the Boolean, the recursion modes for the collections, and then the reading for the actual entries. And then once it is all defined, you can just access them from many set of consumers. Finally, the access pattern here is all executed in the main thread, meaning that the main thread is already the reader for many of those metrics. So all this access pattern is pretty well defined. So you have the logs, you have already the reader limits set in place. Right, so the metrics, the framework is already available on the mailing list. Yeah, it's still in RFC level. Also, the OVS project could try to register an official HTTP port so that deployment could be easier. And then later on, we can maybe think about more improvements. All right, that's it. Any questions?
Okay. Yes. Until we get questions from. Oh, we have a question.
Hello. So you said you contributed already this code, and it's going to be available when?
Yeah, so it has been pushed yesterday on the mailing list. And so, yeah, you can now comment on it.
So the OVS exporter system D service, when somebody curls on it, it runs OVS app-kernel itself internally, or how does?
Yeah, actually it integrates. Actually, it uses the Python bindings. It's a Python HTTP server.
Oh, I see.
But yeah.
And then like what's the time series? Like how many time series is being collected right now? It depends on the number of ports, number of interfaces.
Yeah. It depends on how you configure actually your data path. So if you have many ports, then you will generate a lot of data.
So yeah, just a follow-up question is, let's say that entire metric collection is taking some X time, right? We can't assume all counters are taking exactly the same snapshot. There can be a delay of counter 1 to counter 10, like let's say in that iteration.
Yeah, I mean, it's a single call, so you should see a single, I mean, it's a single reading instance in a sense from the control thread. So you should see something that is coherent, consistent from that level.
But we can't assume all counters are exactly at the same snapshot, but it depends on in the single iteration, all are not at the same snapshot time. That's what I'm just trying to.
I'm not sure I understand the question.
Is the intent of this framework to just be for OVS, or will it be part of libopen vSwitch and can be used by OVN? And
yeah, the idea was that it's a library that can be used by any process that actually builds against the Open vSwitch library. Ultimately, actually, I found also that I'm not happy with the kind of Prometheus client that already exists in C, so it could be independent completely from Open vSwitch. But for now, it uses Open vSwitch facilities for example, string libraries and transformation and so on. So it's integrated in OVS, and it should be available for OVN, no problem. I mean, it's part of the library.
Yeah. Thanks, Ketan, for the presentation. I wanted to know what would be the cost of running this exporter?
Yeah.
So in terms of CPU memory consumption, it would be nice to see with your service, without your service, loading your OVS database completely and seeing how much it impacts the performance.
The cost is a concern in the sense that it's always an issue to slow down those scrapes. But here, considering we do a single CLI call, it's actually it's much better than the other kind of accesses that were not integrated at first. There is just a short scrape duration, so a kind of latency measures that I did actually monitor for some time, because at some point I badly implemented some accesses. So we try to keep that under 100 millisec, but it depends on what you want to access actually.
Okay, we have 2 questions online. I think they are related, so I'll read both and then you decide.
Okay.
Okay, so it's from Joshua. In a multi-tenant environment, is there a way to expose tenant-specific metrics or only holistic metrics within OVS? And the second question is essentially, is there a unique ID within OVS, or do we need to tie it to the interface?
Okay, so I don't know. I guess I will go with the first one. But you do not really have a way to filter right now. I think actually it's needed because a lot of the time the issue is that you have a very high volume of metrics that are generated. So, I mean, keeping all of them when you have a large fleet is always an issue, and you have to select sometimes. So in that sense, I think the filtering should be done in the exporter level. It does not exist yet, but I think that's also a future development that is needed. People will want to configure in the configuration file here of the exporter. You will want to set, define filters and limit the volume of the metrics generated.
So thanks. I think we're kind of running out of time. We can take other discussions offline. Let's thank our speaker again.